everyone, I am Anaheima Pandao from STEM 12-2, and for this video, I will be discussing about the solid and the two types of solid. So we all know that solid has a strong intermolecular attraction that keeps the molecules closer. So what are the characteristic properties of a solid? The first one is that a solid has a definite shape, definite mass, and a definite volume. Second, their intermolecular distance is short. Third, the solid has a strong intermolecular forces, just like what I've mentioned earlier, that leads us to the fourth characteristic, which is solid has an incompressible and rigid formation. So there are two types of solid. These are the crystalline solid and the amorphous solid. The first one, which is the crystalline solid, has a fundamental three-dimensional structure consist of a highly regular patterns of atoms or molecules forming a crystal lattice. One thing about solids is that most of them are crystalline solid. The crystalline solids has four different types, and these are the ionic, metallic, covalent network, and molecular solid. Now, the second type of solid is the amorphous solid. This one lacks an ordered internal structure, but just like the crystalline solid, it is also rigid, but they lack a well-defined structure. For the last part of this video, let us focus on the difference between the crystalline solid and the amorphous solid. First, crystalline has a form and it has a definite geometrical shape. On the other hand, amorphous has no form, thus it has an irregular shape. Regarding their melting points, crystalline melts at sharp and characteristic temperature, while in amorphous, it gradually softens over a range of temperature. If you cut the crystalline with sharp-edged tool, they split into two pieces and newly generated surfaces are plain and smooth. But if you cut the amorphous with sharp-edged tool, they cut into two pieces with irregular shape. Crystalline has definite heat of fusion. Unlike the amorphous, it doesn't have a definite heat of fusion. Crystalline is an anisotropic in nature, meaning some of the physical properties like electrical resistance or refractive index of crystalline solids show different values when measured along different directions in the same crystal. On the other hand, an amorphous solid is an isotropic in nature, meaning the arrangement of particles is irregular in all directions, hence the value of any physical property is same along any direction. An amorphous is also called as pseudo-solid or supercooled liquids. Why? Because some of these solids have a tendency to flow very slowly. The crystalline solid is a true solid and has a long-range order, while the amorphous has a short-range order. Let me show you some examples of crystalline and amorphous solids. In crystalline solid, we have sodium chloride and the quartz. In amorphous solid, we have glass, rubber, and plastics. That's all for this video. Thank you for watching and I hope you learned something in this video. Don't forget to click the like button below, and that's all. Bye!